For section 4.8, we are going to translate equations that are written in standard form. When we do this, we're going to look for and make use of structure, just like we did the same when we translated in vertex form. We're going to use the structure of equations to manipulate them for these translations. So before we go on and learn about standard form, let's just review how to translate in vertex form. So remember, vertex form is y equals a times the quantity x minus h squared plus k. Remember that h is a negative h or a minus h. So when we're talking about translating with h, when it's positive or when it increases, that means that we're going to go to the left. When it's negative, that means we're going to go to the right. With k, that is the y value of the vertex that's being added out there. When it's positive or increases, then it's going to move up. And when it's negative or when it decreases, that means that this graph is going to move down. Lastly, we have a. So when we're talking about a, when it increases or when the absolute value of it is greater than 1, then this graph is going to be skinnier. When it's negative, or when the absolute value of it is less than 1, so it's a decimal, this graph is going to be wider. So we're going to use that information now to translate in standard form. We have 3 steps that we're going to go through when we translate in standard form. There is no way to translate strictly in standard form, so what we're going to do is we are going to convert our equation to vertex form. Once we're in vertex form, then we're going to translate using that information that we had, that we just talked about, the information from the previous section. And then our last step, since we are in standard form, we're going to convert this back to standard form. So there's nothing new in this section. We're just taking actually the past 3 sections. We're taking section 4.4, 4.5, and 4.7, and we're putting them together. So let's go ahead and do some examples. Our first example says translate the equation y equals x squared minus 8x plus 7 left 5 units and down 2 units. So the first thing we need to do is translate this to vertex form. So to do that, I need to go through the completing the square process. The first thing I need to do with that is subtract 7 from both sides. So I get y minus 7 is equal to x squared minus 8x. And I need to figure out what number goes here that completes the square. So I'm going to take the b value and divide it by 2 to get negative 4. And then I need to square that. So negative 4 squared is 16. So since I'm going to add 16 to the right side, I also need to add it to the left side. So I have y minus 7 plus 16 is equal to x squared minus 8x plus 16. Now my next step on the left side, I'm going to combine. So I have y plus 11. And on the right side, I'm going to write this as a squared expression, as that binomial. So I'm going to have x, and I need to use this number right here. So x minus 4 squared. And then finally, to get this all the way to vertex form, I'm going to subtract the 11 from both sides so that I can get y by itself. So I have y equals x minus 4 squared plus 11. So now I'm going to use this equation now that it's in vertex form, and I'm going to translate it left 5 and down 2. So I'm going to think through my translations. With my h is going from -4 left 5. If we're moving left, then that means we're adding. -4 plus 5 is 1. And then my k is going from 11 down 2, so I'm subtracting. So this is 9. And then my a has no changes. It just stays as 1. So my new equation is y equals the quantity x plus 1, so that came from right here, squared plus 9. And then 9 came from right here. So now I'm going to use this equation, and I am going to write it in standard form again. So I'm going to carry this equation right over here. I have y equals the quantity x plus 1 squared plus 9. And now I'm going to go through my steps of simplifying this and converting it to standard form. So the first thing I need to do is double distribute. So I'm going to take this x plus 1 squared, and I'm going to think of it as x plus 1 times x plus 1. If I double distribute, I get x squared plus x plus 1, which becomes x squared plus 2x plus 1. And then every step of that, I still have that y equals and the plus 9. So right now I have y equals x squared plus 2x plus 1 plus 9. And then I just need to combine my 1 and my 9 to get 10. So my equation is y equals x squared plus 2x plus 10. That is in standard form. It is translated, so that is my final answer. All right, so go ahead. That's, like I said, we're just putting the past 3 main sections into this section. So go ahead and pause this video, go through that process with this next one, and then play it, and I will talk you through the video. All right, so with this next one, I, once again, am starting with my equation, and I need to convert it to vertex form. My first step is to add the 9 to both sides. So I have y plus 9 is equal to 2x squared minus 4x. Well, on this one, I have an a value that's not 1, so I need to factor out that 2. So I have y plus 9 is equal to 2 times the quantity x squared minus 2x. Now I need to complete the square inside the parentheses, so I need to figure out what goes here. So I'm going to take -2 divided by 2 to get -1. And then I have -1 squared is +1. So on the right side, I have 2 times the quantity x squared minus 2x plus 1. And on the right side, I have y plus 9 plus, I can't forget that I'm multiplying the whole right side by 2. So instead of just having plus 1, I have plus 2 times 1. Now when I go through and simplify the left side, I have y plus 9 plus 2, which is y plus 11. And on the right side, I'm going to take just my parentheses, and I'm going to write that as my factored expression. So x squared minus 2x plus 1 becomes x minus 1 squared. That minus 1 comes from that -1 right over there. And then I cannot forget this 2 out front still. This is almost in the correct form. Now I need to subtract 11 from both sides. So I get y is equal to 2 times the quantity x minus 1 squared minus 11. Now I'm going to use this new form, and I'm going to write it, or I'm going to apply my translations that happen. So it's going to move up 4, right 1, and then it's going to be dilated by a scale factor of 3. So thinking about what happens here, my h is negative 1, and when it moves right 1, because h is left and right, moving right means that we're going to subtract. So I have negative 1 minus 1, which is negative 2. My k is negative 11. And I'm going to move up 4, which means I'm adding 4. So that becomes negative 7. And my a is 2. I'm dilating it by a scale factor of 3, which means I'm multiplying that by 3. So it becomes 6. So my new equation is now y equals 6 times the quantity x minus 2 squared minus 7. And now I'm going to use that and convert it back to standard form. So I'm going to go over here to my next line. I'm going to rewrite y equals 6 times the quantity x minus 2 squared minus 7. And I'm going to just go through the steps of this process. So first, once again, I need to double distribute. So I have x minus 2 times x minus 2, which becomes x squared minus 4x. Sorry, got ahead of myself. X squared minus 2x plus 4. And that becomes x squared minus 4x plus 4. I still have that y equals 6 times that quantity minus 7 in each of these lines. Now my next step is to distribute that 6. So this becomes y equals 6x squared minus 24x plus 24 minus 7. And then this last step is to combine that negative 7 and that positive 24. So I get y equals 6x squared minus 24x, and then 24 minus 7 is a positive 17. And so this is my final answer. That is all we're doing in this section. You should be good to go to do your homework. If you have any questions, of course, make sure you come talk to me, come work with me, and we will figure them out.